All right, big picture today for the properties. This is going to be one of our best friends in terms of simplifying logs, this particular log property. So one, I'm going to go ahead and prove this to you and show you why this works out. If we have log base 2 of 2 cubed, this is saying that it equals 3, okay? So let's verify this. If I'm in log form, what can I do to change this up? Switch it to what form? What's the base? 2. All right, this is my base here, right? That's my base. What's the exponent for this problem? All right, so here's my exponent. So this is 3. And then what's the only other number left over? 2 cubed. So it turns out that if you are taking the log of an exponential expression here, right, and the base of the log and the base of the exponential expression match, then these have to be the same. Does that make sense? And this is why in the process of changing forms, all right, you're going to end up with like 2 cubed equals x, and then you would have that would have to equal 3. Okay, so this is always going to be true. Here's the thing though, when we have this, there's 2 special cases where it's kind of different to look at, and one of them is going to be if we have log base b of 1, and the other one is just log base b of b. Now log base b of b is really similar to this. If I have log base b of b, what is the exponent actually here? What's the exponent of this guy? Yeah, it's 1, right? But you don't write the exponent 1 when you see it. But because of that, what is the answer? Log base b of b to the x equals x. So if I have log base b of b to the 1, this has to be 1. So log base 3 of 3 equals 1. Log base 5 of 5 equals 1. Log base 10 of 10 equals 1. Log base 23 of 23 equals 1, right? Anytime these 2 numbers are the same, this is really being raised to the first power, and we know from this property that the exponent is the answer. Make sense? Okay, so then we come to this guy here, right? So let's look back at something and consider something. What were the 3 parent function points that we used? If I had like log base b of x, what would my 3 points be? 1, 0. Yeah, we're going to use b for this. b1.
b 1 over b, negative 1.
Negative 1, okay? Now here's what just happened here with all of these, you guys, right? I just evaluated log base b of b, right? So I'm taking the log of b. What is the log of b? 1. It equals 1. Everybody see that? What's the log of 1 going to be then? It's got to be 0. Log of 1 equals 0. So if I have log base 6 of 1, that's going to equal 0. If I have log base 18 of 1, that's going to equal 0. Here's why we can go back to this right here. This is equivalent to saying the log base 6 of, guess what 6 to the 0 is? 6 to the 0 is 1, but what is the exponent here then? 0, so we're still just using this property right here, okay? Now, we don't have to use this property. You guys can always change this to exponential form and solve, but it's kind of silly to always change forms if you're solving if it's such an easy answer. Every time I have like, if I had log base 7 of 1, I don't want to have to change this to exponential form to solve. I want to be like, oh, log of 1 is 0. So for those of you that have a tendency to not practice memorizing things, this is something that would be great to go on a note card. Like do this property and do this property where you have like log base 3 of 3, and then write this property. These are good ones to actually memorize because you're going to use this a lot. Okay. Now another thing that we're going to use with this one is if I have, for example, log base 7 of 49. Okay. So similar to exponential functions, instead of changing this to an exponential function and trying to solve for x, which we can do, instead of doing that, I can rewrite 49 using the base here, right? What is 49 rewritten as? 7 squared. And when these two match, what is my answer? 2. So by using log properties, that's going to save time versus saying, all right, what's the base here? 7. What's the exponent? X equals 49. And then you're like, okay, well, 7 to the x is 7 squared. So now my answer is x equals 2. Well, you can save time. You can be like, oh, wait a second. 49 is just 7 squared. Answer is 2. How do I know that? Because I have my log property memorized. Okay? I will say you will not be able to get away from having this property memorized, so it's in your best interest to do it as fast as possible. All right, this is the one we're going to use the most. So you definitely want to use that. So let's go ahead and go to the examples here. I want everybody to go through and try to do A, B, and C. Go. A, B, and C. Mm-mm. Is everybody done with A? Yeah, what's log base 4 of 4? What's log base 6 of 6? What's natural log of E? 1. Here's why. Natural log, I know some of you guys are very resistant to memorizing this. This is actually going to be a huge issue this chapter. You could almost get away with the last chapter. This one, not so much. You need to make sure that you always recognize that log base E is the natural log, and log base 10 is the common log. You cannot get away this chapter without knowing this. Okay? You have to know that. So coming back down here, we have this, and we know that this is really log base E of E, and at this point you can see it's just like the first two parts. Anytime you have the bases being the same, you know that that's going to be the exponent, which is just 1. Okay. What's the answer for log base 3 of 1? 0. What's the answer log base 5 of 1? 0. This is really log base E of 1, but that's still just going to be 0. And then for this last one here, log base 2 of 2 to the 5th, 5. This is really log base E of E squared, so that's just 2. And this is really log base 10 of 10 cubed, which is 3.